Okay, so in this video, we're going to talk about sketching and how you can use sketches. Okay, this video, I still expect you to follow along and do what I do on my screen. Okay, so we're going to create a new file. So to refresh your memory, you want to have the folder, want the file to be created in open in your left bar. Okay, we can click this plus sign, new design, save the design. I just did Command S on a Windows machine, would be Control S. Okay, and I do Avery dash sketch. Okay, we're going to talk about, well, okay, I'm going to cover some file structure stuff, and I'll do this by looking at an example. Okay, I'll go to the year I counted for my team. Okay, D number 3. Okay, and how this usually works, how you do want to do this is you CAD each part of your robot separately in a different file. Okay, and then you have it all combined into one single file, the master file at the end. Why do you do this? If you were to make literally the entire robot in one file, that file is just going to keep growing in size, and then it's going to be very hard for your computer to open it, for you to view the file, right? So by breaking it up like this, as long as you don't do this thing called break the link, okay, and you don't want to break the link, okay, I'll do show an example. So this still might take a while to open because it's quite a big file, but we'll try. Okay, you don't want to do something called break the link. I'll cover that soon. Because the link is established and still present, it kind of treats each component you import into your file. Okay, and all of these are components, even though they're files. It's like, I know it's a bit confusing. It's the same thing. Each component you import into this file, because the link is still there, is kind of treated as like one entire thing. And so it makes it easier for Fusion to load the file, because it thinks of like 20, 100 different components within that component as like all grouped together. Okay, so we'll let this open. I think it's nearly there. Oh dear. Yeah, I mean, if I open this file more frequently, it would load faster. And like how fast your files load depends on like the quality of your computer, like how good the CPU is and how much RAM you have available, right? My computer here is a MacBook Air with an M1 chip and 16 gigabytes of RAM, so it's like pretty good, but you can get better laptops. You can definitely get a better PC than mine. So if you do, then it will load faster. If you have a worse laptop, worse PC, it would probably load slower. Right? Okay, so now I have my whole file here, and these like 8 or chain symbol thingies, that's how I know that the link is there. Okay, the link is established. And so it kind of treats all these pieces of one thing. And another good benefit of the link is that, let's say one of the other pieces is modified. Okay, and we actually have this present here. The secondary hood piece was modified. We can see the chain, and if I hover over it, it says component is out of date, and we can update the link, right? So if you think about this, what probably happened was I opened the secondary hood file, and I did a minor modification to it. Okay, we can click this update child component button up here at the very top. So I click on it. Okay, and then it will update the link. Fusion 360 here kind of died, but trust me, it works. So I'm just force quitting Fusion to get everything to keep moving on with the video. Okay, important thing to learn from that is how the links work. and how you can update a link, and how to structure a file. You want to have each file of the piece in this, each part of the robot in a different file, and all of it linking back into the master. Another important thing is that once you are done with one part of the robot, like let's say this drive base is complete, we don't want to make any more changes to it, and we're about to put it into the master to link up with all the other parts of the robot. Then we want to right click on the file name, go to rigid group, click yes if this prompt comes up, and click OK. And this creates a joint between all the pieces in the form of a rigid group. And what that means is if I now move one part of the robot, it's probably jointed to the origin, but in the event that you were to move the drive base in like a master file after importing it, if you try to move the drive base, one part of the drive base, the entire drive base will move, and this is very important to making sure that you don't accidentally misalign something in the master file, right? It's possible that after you think you're finished with a section of the robot, you then realize, actually, after integrating it with something else, I need to go make a change. And in that event, what you want to do is delete this rigid group here at the end of your timeline, or you can just find it in the joins menu and delete it. Okay, and then continue working on your file. Then you can go back to moving one piece at a time. You can make changes more easily, and then afterward, after you're done with all your changes, then go make another rigid group, like so, once you're done with the file. Okay, and you'll be set. Okay, so here we go. So document recovery, this is something that happens. You open back Fusion 360, and Fusion 360 will sometimes auto-save a file for you, and in the event where you get a force quit like this, right, you can open that recovery file. Is there any one that I want opened that I just had open just now? Nope. And just delete all of them. And I'll just close it for now. Okay, go back to summer training, sketch. Okay, so now you have that in mind. You have this file structure, right? But sometimes, you want to like plan out things a bit before you actually start CADing, because while it takes a few clicks to move pieces around, right? If you want to move multiple pieces around, maybe it's more complicated, or maybe you have a bit of difficulty just visualizing how this is all going to come together, right? So we can do something called create sketch, and what I did just now was I clicked on S to pull up the shortcut menu. I can type in any command. So let's say I wanted to do rigid group, right? I can pull up rigid group. I can pull up the move tool, right? In this case, we're going to go with create sketch. All right, and then you can create a sketch on one of these three default planes here. If I had pieces imported in this file, you can also create the sketch on the surface of a piece. Okay, so I can click this, and this is not like full in-depth overview of how to use the sketch tool. There's many powerful applications to it, but I'll just cover basics, right? You can create a rectangle. It's probably what you're going to use most, and simplify this. C channel is 1 inch wide, and every 2 holes is an inch. So 35 hole C channel is 17.5 inches, right? We can create this rectangle here, and let's say that represents a C channel, and then I'm thinking, all right, so that kind of represents the drive base. And now I've got some kind of structure here. I can do 3-point rectangle because I want this at an angle, right? And let's say I've got this kind of rectangle here, right? Some kind of slanted thing. I'm thinking we pull in some of those foam discs for this year's game, and we pull it up this indexer here, and then once it comes out the top, it gets shot out with a flywheel. If you have no idea what I'm talking about, check out some of the videos on different robot mechanisms. Okay, so some things we can do with this, right? There are different constraints here, and they let you, well, constrain different lines in different ways. Okay, some of the most useful ones. If you hover over these, they give you a short description, so I'm not going to go through all of them. Okay, you read the descriptions, but I'll just show you some I can use in practice. I'm going to coincident this corner of the rectangle to this line. Okay, so now it's lined up like that, and then I'm going to create. Go to dimension, sketch dimension. Okay, and I'm going to create a clear angle here. Say it's 30 degrees, right? And in theory, I'm going to apply more dimensions. It's also C channel. This C channel is maybe 20 holes long. It's 10 inches long, right? You could use your perfect triangle rules in theory to like create something that lined up that was like, 3, 4, 5 triangles or 6, 8, 10 triangles. Or you could try to force a certain degree, right, and accomplish this by like bending a plate or something, right? But whatever, right? We can plan out the robot in a very general sense. Okay, maybe now I'm thinking there's some kind of support here. Okay, when I'm switching between these numbers, I'm clicking tab. Okay, say I also want this one to be 10 inches long and 1 inch wide because it's representing another C channel. And click down to create that rectangle there. Okay, and then I can co-linear these two lines to make them all lined up. Okay, you'll notice this stuff is still dragged around. It's not fully constrained. Let's say I know that this tower is going to be exactly 5 inches away. Right, and I don't know, this is just coincidented. Okay, and blue lines tell you that something is not constrained. You can drag it around in some kind of way, and black lines tell you it's fully constrained, and this is all fully planned out. Okay, and you can rotate the camera and you'll see it's definitely a 2D sketch. Right, click on the cube to straighten up the view if you ever need to. CADing. Right, so this is a terrible plan, but yeah, you get the general idea of how this tool could potentially be applied. Okay, maybe you look up the diameter of foam disc, okay, and then we can create the disc using a circle. Right, and then you can plan out the flywheel and where you're putting the wheel relative to that foam disc. Okay, you probably want some kind of compression. Right, okay, check out the video on flywheels. And yeah, so you get a sense of how all of this works pretty thoroughly. And when you're done with the sketch, you click Finish Sketch. Okay, so now we have a plan. In some cases, you can point to the sketch directly, though if you ever want to do that, I'm going to go back into editing the sketch. Usually you want to create an actual point. Okay, a point there, right? Then you can point a point to this very easily. It's a point you can actually select and point to point, right? Sometimes you can point a point to sketch. Sometimes it's just there to help you visualize things and you plan it out and you just have to CAD and manipulate things a different way. Okay, but usually once you're done with the sketch, you want to hide it. Okay, it doesn't really contribute to the actual file, and maybe during the very initial planning stage, you want to take a photo of this for your engineering notebook to say, oh, I planned out my robot to look something like this. Okay, but then for the rest of the time when you're CADing, you don't really want to show it. Okay, and so I want you to try around with sketch tool a bit more. Try making some kind of basic drawing of some robot, something you can imagine. Okay, you know what? Do something like a tower going up and an arm pivoting off of the tower. Okay, just try that out. See how it goes. All right, and I'll check out your files in summer training over here. Okay, and I'll save the file. All right, and here we go. Screenshots. Always. Okay, and we're done with that.